Hi everyone, Krishna this side. So in this video, I'll be covering this lead code problem 78 subsets problem. So this will be the problem for the playlist that I have started for the recursion plus backtracking. So I'll be covering from this video onwards. I'll cover all the medium level problems, and these are the problems that I have picked to cover this because they are really important as per the interview perspective. And in future, any new problems that I include, I'll keep on adding into this playlist. Okay, but we will start with this subset problem first, and yes, I'll make sure to explain as best as possible so that we will get good grips upon this recursion and backtracking. Okay, so let us look into the problem statement. We have given an integer array nums of unique elements and written all the possible subsets. Okay, the solution must not contain duplicate subsets. Written the solution in any order. Okay, so all the elements in subsets are unique. Sorry for the background noise, I'm back. So yes, for this particular numbers, what are the subsets that we have? The empty set is there, 1 2 itself individual is there, 1 2 is there, 1 3 is there, then 3 itself is individual is there, then it is like 2 3 and 1 2 3 entire array itself is a subset of itself. Okay, subset is not actually equals to subsequence of arrays, or whatever the sub array that we have, it is not equal to subset. Okay, we can pick any elements from the array and we can create the subsets. Okay, so yes, given this information, let us try to solve this one. We can solve this without help of backtracking or recursion as well. But yes, what we will do is, as we are focusing on recursion, so we will try to solve this one with the help of recursion. So just focus on this screen. Let me launch this and get that one. Okay, so let us suppose we have this array. Okay, 4 5 6 is something what we have, and we have to generate all the subsets. Okay, so see, there is this pick and non-pick something we have. Okay, with the help of this we can solve many dynamic programming related problems, even this recursion related problems. Okay, so this technique is basically used in a lot of different areas, so we even call it as an abstract 0 1 problem. So yes, that is the technique that we will be using, but DP is something not get applied for this particular problem because we are generating all the different possible subsets. Okay, so let us say the option for this particular element, 4, to include it into the whatever the answer that we want to return. It is basically asking to return the list. So okay, so in this current list, whatever the current list that we have two options. Either we can pick this one or we cannot pick this one. Okay, so if we pick that element, okay, currently we are actually at 0th index, I equals to 0. So this is the array that we have. Okay, at 0th index, whatever the element that we have, either we can pick it or we cannot pick it. Okay, even if we do not pick it, there is a sub array that is formed. Okay, so yes, we have two options. Either we can pick that element or we cannot pick that element. So what is the options we have? So 4 is basically, if we pick, what we will do, we will add it into the list, or else if we do not pick it, the array list is basically empty. So at 0th index we picked it, so it is 4, the array list. We do not pick it, the array is empty. Okay, it will not be having 0 as well. So yes, now that is done. So I basically now get shifted. So this is the pointer that we are pointing. Okay, currently at we are 0th index. Starting from the 0th index, we are trying to see. Now what is the next? I basically get incremented to 1. The current list is basically 4. Now for this 4, what is the option for this 5 to include it? So again, two options we have. Okay, for each element we either pick it or we do not pick it. Now again the same thing, whatever the current list that we have, we either pick it or we do not pick it. If we do not pick it, whatever the current list that we have, it is going to be the same. Okay, now I get incremented again. Now for this current list, what are the options to include this whatever the index that is there at ith index? So 6 is there, right? Either we can pick it, okay, or we do not pick it. Okay, these two options are there. Again for this 4 as well. Okay, so now the moment we reach I equals to 3, okay, we will explore for the 4 as well for the possibilities. Whatever the array size that is formed, whatever the current list that is formed, that is something what we will add it into the answers list. Okay, into the answers list, whatever the value that is formed, the moment we reach out of the point, because further from this here I equals to 3, we are going outside of this array, so we do not have any further possibilities. Whatever the list that we form, that is something what we will add it into the answers list. So 4 5 6 is something what added into the answers list. Now here we do not pick it. So 6 is something what we picked, and here we did not pick. Now I got incremented for this as well, and this is the answer that we have. So that is something got added into the answers list. Okay, this is done. Now what next? For non-pick, okay, the 4 is something what we haven't picked. Okay, that was the possibility that we have. Okay, so what was this? Okay, so that was possibility right over here. Either we pick it or not pick it. Okay, now here it was basically we picked it. Okay, now when we are at I equals to 1, we did not pick 5. Okay, in this case we picked 5. Here we are not picking the 5. So for whatever the list that we have, that is going to be there. In the next one, we can either pick this one, whatever the element that is there at index 2, we can pick it. So if we pick, it is like 4 6, and if you do not pick it, it is like going to be the same 4. Now the moment I equals to 3, whatever the list that is generated, that is something what we will be adding it into the answers list. Whatever the list that we got so far, that is something what we will add it into the answer list. Now all the possibilities are done for this one. So for 4 we explored all this. Now when we do not pick 4, okay, when we do not pick 4, here also further possibilities are keep on starting. Now at first index, whatever the value is there, either we pick it or we do not pick it. Okay, so when we pick it, I equals to 2, at this moment again we have options for the 6. Okay, because the I is basically pointing to 2 and 6 is something what we have. So what are the possibilities? Either we pick it and add it into the list, or we do not pick it. Now I is equals to 3. This is whatever the list that is formed, that is something what we will add it into the list. Whatever the answer that we got, that is something what we will add it into the list. Now this is done, we will backtrack and keep on going backside. Okay, now for this particular one where we did not pick 5. Okay, for this one, either again at the whatever the values there at the second index, that is something we can pick it or we do not pick it. So whatever the answer that we got, we will add it into the list when I equals to 3. Whatever the answer that we got, that is something what we add. This way we will generate all the different possibilities. Okay, we are not missing any possibility. Even the empty set is something what it will keep on getting, and at each element we are not picking it, and that value is something what generated. Okay, the empty array list is also generated. So this way we can solve this one. Okay, let me write down the code and then again we will walk through another example that we will get clarity about it. Okay, so let me create this array list of integers. Answer list I'll name it as, and equals to new array list. Okay, the list has been created. That list is something what I want to return from here, return on the answer list. And let us create here the backtracking function. Let me name that collection list. In this collection list, what I pass is like the zeroth index from where we are starting, the I value basically from the zeroth index we are starting it, right? Okay, now that is something what I have added, the size of the array till where we actually want to go, and the arrays, and basically the list. Okay, in the list where I actually want to fill the data. uh, so it will be new array list, new array list. Okay, these all different values are passed into this recursive functions. And in this one, what are the conditions? So it is like public void collection list. The first value is basically the integer index where we are at, the length of the array, and then there is nums array, and then there is array list. Okay, so array list of integers, integer, this is current list. Okay, see, the base condition was pretty much straightforward now for us. So whenever this I value is actually equals to size of the array, whatever the list that we have found in this current list, that is something what we will add it into the answers list. So answers list I already created, dot add new array list. In that one we added this current list. Okay, that is done, and from here we will return, so that further no callback will be happening. Okay, the same function we don't want to call again and again. Now the first thing that we can do is we will be picking this one. If we are picking this one, so what we do, whatever the current list that we have, in that one we can add the value at that current index, nums of I something what I'll add it. Okay, nums of I something what I have added it, and again I can call the same function. Okay, so this way I picked that element. Okay, this is for the pick logic, and we will go to the next index, and n is basically the same, nums is basically the same, current list is going to be the same. Okay, this way pick that element. Okay, now I don't want to pick that element, so this current list, from this current list I actually want to remove that element. Okay, so in the current list, whatever the size of the list that we have, current list dot size, the last element that we have added, this currently the current list size is 1. So that the numbers of 0th index, whatever the value that we have, we added it, that is something what I am removing it. Okay, so Here I removed that value from the current list, and I'll call same function with empty list, or whatever the data that we did not pick, that is something what I removed it. So this is for the pick logic. Okay. So first it will try to see all, generate all the pick possibilities. The moment it is done, it will keep on coming and returning back to this one particularly. The moment this function is done, it will go to the next one, and it will try to again do not pick that whatever the value that we have added previously into this list, that is something will get removed at last, whichever the value that we have added while trying to pick all the possibilities. Okay. See, this will get stopped the moment I is basically equals to 3, because the size of numbers array, if we consider for this particular example, it is going to be 3. Whatever the list, while picking all the elements, the data is generated, that is something we will add it and we return it. The moment this function is done, the last value that we have added into this current list, that is something what we will remove it and we call the function. Okay. So how this works, let us suppose we have 4, 5, 6. Currently, initially, we can pick 4. Okay. In the current list, 4 is something got added, and I pointer is got moved from 0 to 1. Again, we come here, we check that we are not satisfying. This is the base condition. We already discussed like why we require the base condition to not go infinitely into the recursive calls. We require the base condition. Now in the current list, I have added this 4. Okay. Previously I have added, and this is something I called with updating the I value. Now I is basically basically it is basically 1. So again we come here, we check that if it is satisfying this condition. No. So again whatever the value is there, that is something what we added. So new list is like in the new call back, it is like 4 and 5. Okay. We are picking that whatever the value that is there, that is something we added into the list at that ith index. Okay. Initially I was at 0, here I was actually equals to 0. At this location I is actually 1, so whatever the value is there at 1 first location, that is something we added. Now we picked it, again we call this collection list. Again we reach right over here, the I value is basically 2 now. Okay. Now I value is basically 2. Again we are picking whatever the data that is there at that location. Okay. Okay, whatever the data that is there, that is something we picked it and we added it. So at second index, 6 is something what we have at I equals to 2. 6 is something we have. Okay. So 6 is something we have. So what I do, I add it into this list. Now again the I value get incremented. I is basically equals to 3, and we will enter into this one the answer list that I have created. In that answer list, we will add this current list. Okay. The moment this current list is added with having this 4, 5, 6. Okay. We are done, we are returning back from there. Okay. Once we are returning back, we will reach to this particular function. Okay. Because from there only we checked when I value is basically 3. Now next line will get executed. So in the next line, what we are doing, whatever the last value that we have added, that is something we are removing it. Okay. Whatever the last value that we have added, because I actually don't want to pick this one. Okay. In the answers list, what is been added now, 4, 5, 6 got added. Okay. Now we don't have to bother like if I remove this value, what will happen, right? So since the answer list got updated with this particular one, I can remove this value. Okay. Now the new this value, once we have removed, we are again calling the same function. So I value is basically 2 at this one, so I get incremented to 3. Again whatever the possible subset that we got, 4, 5 is something what we got, right? When I equals to 3, that is something we will add it into the answers list. So 4, 5 also got added. Now the moment that is done, again what happens, this function is basically done. So previously where this call has been there, okay, previous time at this particular location, there we reach. Okay. And what we do, basically whatever the 5 we included for this one, we will remove it from the tree. Okay. The 5 will get removed, and the call stack will happen like that only. Okay. I already explained like we are either picking it or not picking it, and we have to remember like from where the previous call has been done. Okay. Until and unless the current call is completely done, we cannot go back to the previous call. The moment we reach to the previous call, we are simply removing the whatever the data that we have added, and we are again calling without that data. So that way what happens, 5 will get removed, 6 will get added, 4, 5, say 4 and 6, this will also get included in this one. Okay. This will happen at this level. 6 will be there, because without including that value, we are calling this one. Again the moment this is done, it will go previously. So all these values will get removed, and empty 4 will be there, and we are not picking any values at each location. So 4 is something what we get answer into this answer. Okay. So that way we will done with four all the possibilities. Now next is like without picking this four, we will reach right over here at this location, and we are actually including five or not including five. Okay, the moment we are including five, next is like we are again we are including six, and whatever the answer that we got, that is something we will add it into this answers list. The moment this is done, we are not having any further calls, so we will remove it. So once we remove it, whatever the answer that we got, that is something this collection list will call. So five is again get added into this one. Okay, this is once this is done, the empty is been there. Now at I equals to 2, again the empty array is something what we got so far. So first we can include either the 6 or we do not include. So the moment we include it, I equals to 3 and 6 is something get added into the list, and then it is like empty whatever the array, we are not picking anything till the end of this. So this is how the answers get generated from this one. Okay, so yes, I actually made some confusing at the end. I should have connected and shown you again with the help of tree diagram, but I think first example what itself pretty much clear for all of us. So this is like not picking that current data, and we can easily remove it from the list, and we can generate the answers. We will recursively call it, and we can keep on generating the answers. So this is if we run this code, it should run fine. And talking about the complexity here, time complexity, it is okay. Wrong answers. We made some mistakes. Okay, we added the data, we removed the current list data, and we are calling the collection list. What is the answers it is generating? Okay, okay. It was pretty much used. What mistakes I have done? Okay, I equals to n answers dot add the current list that we have. From the current list, we are actually adding nums of I. I equals I is basically getting increased, and n is something we have nums current list. Again from the current list, we okay, it should be removed, right? Sorry for this silly mistake. Okay, we are actually removing it. I think some of you guys have already noticed this when I was writing. So yes, we actually are removing. I actually thought I actually copied it and did not modify it. Okay, so this should remove the data. Whatever the current last value that we have added, it should be removed so that we are not picking it, and we are again recursively calling the same function. Okay, so this is getting accepted. So the complexity is going to be it is like for three possibilities, we are generating eight lists. Okay, so it is like 2 to the power of 3 possibilities we are generating. Okay, which will be equals to 8 subarrays are something what we are generating. So if there are 4, 2 to the power of 4 is something we are generating, so the complexity is going to be 2 to the power of 4, and we are keep on calling this n time. Okay, for each indices. So this will be like n into 2 to the power of n is the complexity that will be going to get. Okay, so yeah, that's all from this particular video, and we'll try to solve all these problems as soon as possible, and I'll make sure to upload all those videos so that we will get a good grip upon these subsets or these recursion problems. Okay, recursion plus backtracking. So once we are getting clarity with these recursions, I think we can start looking into the DP and graphs, and again we can focus on the other areas where we can utilize the recursions as well. Okay, so yeah, that's all from this particular video, and yes, with this particular series I'll make sure to get good amount of grip upon this recursion. Okay, so yes, just stay tuned and try to practice by yourselves. Okay, without pen and paper you cannot get idea about this recursion, so we require a lot of practice for this recursion, and we have to build them in our memory also. The recursion tree that I have actually shown in the first, that tree is something we have to generate in our memory, so that at any point in time whenever we are backtracking inside our brain, we should get to know that okay, now this is the operation that I can perform. Okay, so this was the base condition, this was a recursive call while picking, this was recursive call while not picking that element. Okay, so that's all from this particular video, and thank you for watching this one. Bye.